This is our parent workshop series. We try to do 5 or 6 a year. So now that you come and visit us tonight, it'll be on our email list, and we'll let you know when we have future events. Hopefully you'll be able to come to and help us spread the word at your children's schools. Or if you're a teacher, welcome and help us spread the word to other teachers. These are often topics that work really well for both parents and teachers. And if you've also been to these before, you'll know that for some reason these workshops are technically cursed. And I'm like now onto the third piece of machinery I'm trying to make work tonight. So in the beginning, don't mind me running back and forth. We're just trying to get things set up for the next part of the presentation. But we appreciate your patience with that. And so with that, let me introduce our wonderful speaker tonight. We have Mary Foster. She has been a teacher for over 40 years, primarily in the Vallejo school system. And she noticed into her teaching that there were students that often seem to have trouble accessing math facts and needed a new strategy for how to acquire that knowledge. And so she actually, through her own research and trial and error, developed this method, lots of trial and error, and now is working as a math consultant and teacher coach. And she taught Barbara and I how to do this in Barbara's office one day, and we were like, oh, that makes tons of sense. And so I think you'll find this really interesting and something easy to take home. You can take home the slip covers and the markers and with you when you go today, because you'll see why after you do the activity. And with that, I'm going to hand it over to Mary.
Glad to be here tonight. I'm going to have to get used to 2 microphones. This one's for the filming. I'd like to start by letting you in on some stuff that I was doing over the summer. I've been working at trying to learn more about how kids acquire math knowledge and how they get the number sense that they need. And by number sense, I mean the feeling that numbers make sense to them. They kind of understand how numbers work. Okay, and the reading that I was doing this summer was really interesting. And let's start with preschool. Okay, they find that before a child enters school, they generally acquire some number sense, and they've been able to use that as a fairly good predictor of how well students will do later in math. Okay, it's not 100%, but it certainly is a good predictor. So let me tell you what that is, because if you have young children that haven't started school, and I really don't know, I should probably ask you, how many people have children that are pre-kindergarten that came tonight? Okay, whether that's the one you came for or not, that you have some. And how many have K1 and 2? Oh, good. Okay, and 3, 4, 5? Great. Okay, we're going to go through all of that and show you what will help. And of course, if you have younger children, hang on to this packet because they will get to that. But I'm going to give you all the precursors first. So before they get to kindergarten, most kids that are going to be successful in math acquire a sense of number that they express as being able to tell you there's one bird. They know one. They have a sense that one is a word that associates with a quantity 1. That's a really important piece of information. And the same thing for 2 and 3. So if a child comes into school knowing 1 plate, 2 cookies, 3 rocks, okay, that's a good sign that they're on the track to acquire that. Now, how do they get that? They get that by parents pointing and saying, look, 1 bird. Look, 2 dogs. So it comes from parents. And that's something that they need exposure to. So if you have friends with younger children, share that, because that's something they need. They just need to get that, and they're only going to get it if they keep hearing it. They're not going to get it with worksheets. They're not going to get it with, they might get it, I don't know, watching Sesame Street these days. There's a lot of stuff on there. But just expose kids to that. Now, they get to kindergarten and they start to acquire the ideas that numbers mean something. That's what we mean by number sense. It means something. Okay? So what do kids need to learn? And I'm going to have a hard time doing this with one hand. What do kids need to learn starting in kindergarten and moving through first and second grade that will help them have the sense of what number is, the relationship between numbers, and how to use numbers flexibly? That's something that's really important as we move up, is to know how to use numbers in more than one way. We call it composing and decomposing numbers, where you can see 5, but you also know that that's 3 and 2, or 4 and 1. That you can say, how many ways can you make 6? And they know how to put numbers together to make 6. They can take 6 apart. Okay? And I don't know how to do this with one hand. Sorry, I teach with both hands. One of the things that you can do is teach children to show on their hand what numbers are. Okay, show me 1, and they show you 1. Okay, they should be able to show that and understand that the quantity is 1. That they pick up really easily. Same thing, show me 2, show me 3. Recognizing quantities, and if you put your fingers up and say how many, without counting, they can recognize 2, 3, 4. Okay, you move on. They should be able to after you've worked with those, they should be able to recognize and show you 5. Okay, now this is something that takes a while. Don't try and go home to your kindergartner and do it all in next week. But it's a process that happens. But it's something that gives them a physical contact with the numbers so that they can make a connection not only with seeing it, but feeling it, okay? Which seems to help some children, and since we don't know early on which ones are going to need to do that, we try to make it accessible to everybody. So there's showing me the numbers. After that, can you hold this up for me so they, thank you, sorry. After that, they move to 6, okay? They need to recognize that this is 6. Most kids will do that in school. The teacher has them show numbers. What they don't necessarily do, and what you need to help them do, is to notice that that's 5 and 1, that 6 is 5 and 1. 5 is a big anchor number for kids. Why? Because they have 5 fingers, and because 5 and 5 makes 10, and we have a base 10 system. Does that make sense? So this is a number that they can use, a number combination that they can use. You move on to 7 is 5 and 2. 8 is 5 and 3. 9 is 5 and 4. Okay, and then they pick up 10 is 5 and 5 really fast. That's an easy one. Thank you. I appreciate that. So they've learned those combinations. Those combinations are, one, going to be very useful in the strategies we're talking about tonight. But what else it does is it gives them a way to think about numbers that is not 1 by 1. Okay? We want kids to be able to recognize groups of numbers, recognize relationships between numbers, and use convenient numbers so that they can do some problem solving and some manipulating with numbers in a way that will make sense to them. It's kind of like giving them permission to think in certain ways. Now, let me tell you something that I've seen at classroom I was observing, and the teacher had the kids hold up 7 fingers, okay? And she said, now take away 2. And the little girl that I was behind went, she took away 2. She was so proud. She knew what 2 looked like, and she could take it away. And the teacher said, oh, no, you can't do that. And made her put her fingers back up and count them down. 1, 2. Which is kind of, yeah, I know. We want just the opposite, okay? Because one of the things that I've seen, and I've taught everything from kindergarten to second-year algebra in high school. I'm sorry, it keeps cutting out on me. Is that kids love love math in kindergarten and first grade, and they love their kindergarten and first grade teachers. And whatever your kindergarten and first grade teacher taught you is probably still in there somewhere. But they take it with them to second grade and third grade and fourth grade and fifth grade. They're still quoting their first grade teacher in fifth grade. And one of the things they inadvertently acquire, and this isn't on purpose at all, but they start thinking that the only permissible way to do something is to count it one by one. And so that intuitive grasp of 2 that my little first grader saw when her teacher had her do that, they still have it, but they learn not to use it. They learn, I'm not supposed to do that. And it's not on purpose. Nobody ever set out to do that. It's just that it happens. And so if you teach kids to work in groups of numbers, show me 4 does not mean 1, 2, 3, 4. Show me 4 means I know that's 4. Okay? Because I've always got 4 fingers up here. This is my thumb and it makes 5. This is 4. And I can recognize that as a group of 4 that I can work with. Okay?
Like looking at a word and being able to read a word versus having to phonetically sound it out.
That's right. Thank you. But so that's kind of where we're going with that. It's trying to give kids the ability to be flexible with numbers. I've taken classes in, let me say it right, cognitively guided instruction, which is a program that is being used in Davis and other school systems. We've got some teachers in Vallejo that are trying it out. And what they do is they give kids problems and manipulatives to work the problems without telling them how to do it. They figure it out for themselves. And we have kindergartners. I've seen kindergartners doing multiplication problems, word problems in multiplication, and they know exactly what they have to do and put it together, and it makes sense to them. They have a lot of potential, but they need to be able to have that permission to think. And if you've got manipulatives and blocks and things that they can work with, great. But they've always, always got fingers. We know that. And if they know how to use them properly, they can really gain a lot from it. So that's kind of the background. Okay? Now, where did we start? I don't know how many of you have kids that are trying to, in third grade, that are trying to learn their multiplication facts right now. Yeah. Well, that's where I started, is I saw a lot of third graders who really, really tried. Okay, they really wanted to know those facts, but they couldn't get them. And the textbook wanted them to learn all their 3s in one day, and then all their 4s the next day, and then all their 5s, which was pretty easy because they all could count 5s. And then the next day was 6s, and then you've seen that before if you have kids that have gone through it. And they don't do that. You know, we really can't expect that they're going to do that. And they were spending so much time counting out 1, 2, 3, 4, 5, 6, 7, 8. And then I need another 8. 9, 10, 11, 12, 13, 14, 15, 16. And now I need another 8. Wait a minute, what did I say? And then they go back and they start again. And they're really trying, but they aren't being given a strategy to figure out how to get there before they memorize it. And that's what I was looking for. And I wanted something not only for the kids who usually will get it eventually, because I think it's important for us to give them that right away so they can do all the things that the textbook is asking them to do, but also the kids who would struggle all year and not get it. For the kids in 4th grade who had struggled all the way through 3rd grade and still hadn't learned multiplication facts, wanted to, had developed their own strategies with, 8 tick marks and 8 more tick marks and then 8 more tick marks and then 8 more tick marks, not even using tally marks, but just single marks all over the page. And when they got to 5 times 24, they would write 5 down 24 times. and then count the 5s, because that was a strategy that they could use. But we weren't giving them anything more useful than that. And I wanted to find something, sorry about the background, but I want you to know where I was coming from. The other thing that I tried to build in, which is why it is the way it is because I just wanted them to be able to make one decision. Okay? There are a lot of strategies to teach addition. There's a thing about this is what you do when you add 9s. And there's another thing about the doubles, and the doubles plus 1 and make it 10, all useful things. And the idea of using doubles, doubles plus 1, doubles plus 2, make it 10, are all part of what I was telling you about the flexible ideas. Okay, those are part of things that we want kids to be able to do, is be flexible with number. But they'll get that in their classrooms probably. That's in most of the textbooks. The problem was that kids who were confused could learn each of those strategies on a particular day. If you taught them to use doubles, they could do doubles that day. But when they came back the next day and you taught them to do doubles plus 1, they go, wait a minute, that doesn't look like what we did yesterday. And then you teach them make it 10, and they learned how to do that, but then they forgot about the doubles. It happens because there's so much happening at once. So I wanted to find something that they could make one decision, just one, and that would tell them use this strategy or this strategy. And one would be pretty obvious, and the other one would be the one that we would teach. Okay? So that's what I went after for multiplication, and came up with it. And then teachers were going, well, if you can do that for multiplication, how about doing something for addition and subtraction? Addition took me another 6 or 8 months to figure out, and it was so easy, I can't imagine that it took me that long. You'll see what I mean. And subtraction took me another year to come up with something that had one decision point, just one. So I'm not saying this is the only way that you can teach kids to understand addition or subtraction or multiplication. This is something that gives them one decision to make. And it gives them the ability to use numbers in a flexible way, and it gives them the encouragement to think of their own ways to use number. If they can get the sense that they can move numbers around and use them the way it's convenient for them, then we can also see that they will be able to use other strategies. And thinking about math flexibly is a hallmark of a good mathematician. Okay? So we're going to help them along that path. So let's take a look at the first page, which should be addition. And, okay, you'll be looking at it. And let me tell you what I came up with for the decision point. Okay? And so this might be, oh, okay. Sure, that would be fine. So the decision point on addition is, do I count it or not? Okay, that sounds like a pretty easy decision to make. Do I count it or not? And you establish that counting numbers are 1, 2, 3, and 4. Okay? Those are the counting numbers. If you have a sum that has at least one counting number in it, they can get that math fact. If they don't remember it, they can get it by counting. Counting is the most efficient way to get it if you're counting 1, 2, 3, or 4. Does that make sense? Okay. So if I wanted to, say I have 4 plus 3, and this is taught in the schools, find the larger number, which is 4, and then I'm going to count up 3. Okay? So I start with 4, and you can teach your kids to say the 4, point to the 4, write the 4, okay, different ways depending on what they're getting in school and what they need, and you can judge that, and then count up 3. Now if they're younger, and you're using this with younger kids, say 1st and 2nd grade, start with Skittles or Barbie shoes or pennies or something else that they can use. How many manipulatives are you going to give them to count up? 4, because they're only allowed to count up 4. We have another strategy for the bigger numbers. Okay? Then counting up is very quickly, you can do it with objects. I have 4. I write the 4. I point to the 4, but I do not count the 4. Okay, that's important. I'm not counting that 4. I'm only counting the next number, which is the 3. Okay, so here I start with the 4 and I count. 5, 6, 7. Now, what do they need to be able to do that? They need to be able to know what the next number is after 4. So that's something else that you would add to that list of things that you're going to do when you're working with your kindergarten and first grade, is just asking them what comes after 5, what comes after 8. Okay? Not stressful, nothing, just ask them and have them thinking about that once in a while. Play it in the car. What comes after 3? You know, that kind of thing. So that by the time they get to the point where they're going to need to use it, it's there. I use Smarties a lot. They come in the rolls. I bought the huge bag at Walmart last night for $2.37 because the day after Halloween or 2 days after Halloween is the best time to buy candy, especially if you're a teacher and you're using lots of it. And then you give them 4 pieces, and so they're sitting down there with their homework or something that you're practicing, and you point to the 4 and you say 4, and then you go 5, 6, 7. Yay. Okay? Does that make sense? So that's counting. Then from moving from manipulatives, and for the older kids who may only need to do that a couple of times to see what they're doing, they use their fingers to count up. And this is something that kids are used to doing. This is a strategy that they develop themselves. They go 4, and then they go 5, 6, 7. And they can see that they've put up 3 fingers. They need to be able to see 3 in order to know where to stop. If they haven't practiced knowing what 3 looks like, they may go 4, 5, 6, 7, 8, 9, and they don't know where to stop. And I've seen that. They need to recognize the 3. That's another good reason for having them learn what a number looks like, so they can look at that and know if they've got 3 fingers up. Okay, so you're counting for the addition. But let's go to the next step, okay? That one's pretty easy to understand. The next one involves numbers that are not counting numbers. So if 1 through 4 are counting numbers, and 0 you don't count. 0 is more like a pattern. If I'm adding 0, I don't change the number. And you can work on that, but that's not really something that they need to work with too much. Let me just show you. Oh, my things have moved. Okay, hold on. Okay, so if it doesn't have a 0, 1, 2, 3, or 4, it has a 5, 6, 7, 8, or 9. And if you want to show me, show me 6 on your fingers, please. And how did you show that? 5 and 1, okay. Show me 8 on your fingers. How did you show that? 5 and 8. Okay, show me 9 on your fingers. 5 and, okay. Do you see that there's an anchor number in every one of those? And by the way, how do you show 5? 5 and 0. Okay. When you start teaching them this, show them 5 and 0. Okay, why would you do that? I'm seeing quizzical looks. And I'll show you in just a minute because it makes a difference. So you have a 5 in every one of these numbers. And I actually got this from a 2nd grade class. It was an after-school class of little boys who hadn't learned math facts and weren't going to, period. They were too busy to do that. So I had them add on their toes. And here's what they did. How many toes did they have on this foot? 5 of them. And how many it took to make 7? 2 more. So they'd show 2 and 5 on this side. And then they would put 6 on the other side. So how many toes do they have over here? 5. I wouldn't let them take their shoes off. I said, because you can only use 5. You can't use 4 toes. You can only use 5 toes. And here's, I said 6. So hang on a second. Now, what's easy to add here? Five and 5, yeah. Most kids will know 5 and 5 is 10. That's how many fingers you have. So we can add those, and that makes the 10. I write down the 10 first. How many fingers? 3. That's the ones. What have I got? 13. It's really, really easy. Now, you don't have to teach it with toes, but it's a fun way to do it, depending on your child. If you have a 4th or 5th grader that's learning facts, maybe not that one. They get a little insulted at that age pretty easily. But that's what the idea is. If they write 6 plus 7, if they have that as a fact that they're trying to learn or trying to add, how can they write the 6? Have them look at their fingers. How do you show it on your fingers? 5 and 1. How can you write it? 5 and 1. So instead of 6, I'm going to write 5 plus 1. Is that okay? And go through it with manipulatives. Show them that if they have 6, they can take the 6 apart and have a group of 5 and a group of 1, and that's okay. 7 is written 5 and 2. Again, start with manipulatives, fingers, and then written. Now, what can I add? Again, I'm going to add the 5s. I know that's going to be 10. I add these, and I know that's going to be 3. Here's the 10, and here's the 3. How do I know that's in the 10's place? Because I know I'm going to write another number after it. And I know that will make it into 10's place. Do they have to know 10's place to learn a teen number? Is 10 and 2? Not if you teach them to read teen numbers as 10 and 2. What's this? 10 and 8. What's this? 10 and 7. What's this? 10 and 4. 10 and 4 is the same as 14. And we have a whole number sense unit that's specifically developed for K1 that uses 10 frames to do this. And maybe they'll invite me back to do that one someday. So anyway, that's the strategy right there for addition. So they have 2 choices, 2 things. Do I count it or don't I count it? I do count it, count. If I don't count it, I pick out the 5s and I add them quickly. That keeps the kids from having to struggle through the I don't have enough fingers to show 13, because they will count out the 6 and then they will count out the 7. Only by the time they get to the middle of the 7, they've already used up their fingers. So they put their fingers back down and they keep counting out the 7, but now they've lost their place. Or the answer is 3 because that's all the fingers they have showing. There are a lot of places that I've seen students go wrong, and this seems to help them with that. You don't have to have fingers. Now, eventually, after a few weeks practice with this, they learn to do it mentally. Okay? Now, let me have you take the first loose sheet and slide it into your sheet protector, because this is what you're going to do with your students, children. The addition sheet, yes. These are all, A-L-L, all the problems that they will need to use with this method. Because every other addition fact from 0 to 9, it has a 0, a 1, a 2, a 3, or a 4 in it. This is all they have to do the strategy with. That's pretty impressive, isn't it? It is when you show it to children. They like that. But these are all the hard ones. That's all the hard ones. There are hardly any left. Did I walk off? No, I didn't. And I want you to make sure that you don't write on this one or the one that's in your packet. This one you're going to use with your student. It's going to get tagged, beat up, erased. I'm sorry. Oh. Oh. Okay. Thank you. I don't know. Anyway, so you're going to use the marker that the district gracefully bought for you. So this is what you're going to use with your student. This is in the sheet protector. Why? Because you can use the same sheet over and over and over to practice as many times as they need, and you never have to make copies. Teachers appreciate that too. We love sheet protectors. So let's try right now. Get your marker, and you have your sheet in there. And, okay, the first one is 5 plus 8. Sorry, I took my glasses off and didn't put them back on. All right, so what would you ask your child to show you for the first part? Show me 5. Now, how are you going to teach them to show you 5? 5 plus 0. That's almost right. Because what you're going to write down is 5 plus 0. Why? Because when a student doesn't learn it that way, and that's how I started and found out the hard way, is that they will think that 5 is the number they're going to add to the 3. They will just move the 5 over to the other side. So what are we going to write for 8? 5 plus 3. Okay? So they're practicing this. And now you can see that they can add the 5s to make 10. And then add the 3 and the 0 to make 3. And what are you going to get? 10 and 3. And teach them to write the 13 down as 10 and 3. That's part of being flexible about number, okay, that our kids don't always get in an understanding of teen numbers. It is absolutely amazing to me that if you ask a 3rd grader, a 4th grader even, what is 10 plus 8? They have to stop and think about it. They count up. They go, okay, that should be second nature. If they understand the base 10 system, they should know there's the 10 and there's the 8, it's 18. Give them that gift of knowing that, because they're going to also need to know it for 20 plus 4 and 30 plus 7. Okay, because there are then some flexible strategies that they can use with adding 2-digit numbers mentally, and they address that in 2nd grade in California. But they need to be able to say 30 plus 7 is going to give me 37. So this is a good place to start. Okay, so go ahead and try the next couple and see how it feels. Now there is an answer sheet that goes with this in your packet, so you don't have to remember what it all looks like. Okay, I have it written out for you in the packet. But I want you just to get the feel of how is it that you think about how you're going to present this to your students. What are you going to write? What is it going to look like? And how long is it going to take them before they're going to want a shortcut? So you offer them a shortcut. Because if they're ready for a shortcut, they're going to eat it up. And the shortcut is making part of this mental, because you want it to be mental. Okay? The writing is a step in the right direction, but it isn't the final answer. Okay, now, what can they do mentally, do you think, that they won't have to write down? What part is always consistent in this method? The 5s, good. So we've got, eventually they're going to move to this, and let me, okay, can everyone see that? All right, so we have 8 plus 7. I'm going to think the 5. I know if it doesn't have any counting numbers in it, I know it's got a 5 in it. This is 5 plus 3. Am I going to write down the 5? Nah. I've done that enough times. I've practiced it with you. At least a couple of weeks before you let them take the shortcut, okay? Depending on their age. So I'm going to write down just the 3. I remember the 5 is here, but I'm not going to bother writing it down because the 5 is always there. It's this number that's different. And 7, it's 5 plus 2, so all I'm going to write down is the 2. And then I add those up, that's 5. What part did I not write down? The 2 5s, which makes a 10, it's always a 10. It's always going to be written this way. 10 and 5 is 15. So they start to skip the step of writing the 5s, okay? Now, at that point, they can start doing it surreptitiously on their fingers. And they may try this, and you let them do it if that's how they want, because we want it to be something that makes sense to them. And if it makes sense to use their fingers, let them go for it. Okay? What you can do is the same thing I had the little boys doing, except without mentioning the toes. And that is, I would have 8. Well, I know 8 has a 3 with it, and I know 7 has a 2 with it. So I'm just going to put these fingers kind of under the desk, you know, so nobody sees that I'm doing it. But I'm going to look down there, I'm going to see 5, so I know it's 10 and 5. Oh yeah, 15. 8 and 7 is 15. Now, if you want to encourage them to memorize their facts, and you do, I am not saying that this is instead of memorizing. I have never said that. It is giving them access to the right fact until they can memorize it for themselves. Okay? This is to get them through those hard days of 3rd grade, or the frustration that they're still in 4th or 5th and haven't gotten it, or in the first days for this would be more like 1st and 2nd grade, where, okay, how do you get this? You know, where they're supposed to be memorizing it. That's another piece of research that I read this summer, by the way. They tested 1st graders in high districts, medium districts, low districts. You know that California says that 1st graders need to have their addition facts and subtraction facts memorized by the end of 1st grade. They don't. They don't have them memorized in high districts or low districts or medium districts or any districts. A couple of kids will have them memorized. A number more will have strategies that they've figured out for themselves, and they're using the strategies. Okay? But they are not memorizing them. Okay? So giving them strategies that are efficient, that make sense to them, is something that we're helping them with, because they're going to do it themselves anyway. And the way they come up with might not be as efficient, might be more frustrating, might be more prone to error. So that's what we're doing. Question?
My son's at a point where he struggled all through the multiplication now, but he's got it memorized pretty well.
Mm-hmm. If you want to teach him this as a backup, so if you get stuck, this would be great. If he's in 3rd grade right now learning multiplication, 4th grade, teach him the multiplication method first, because he's got strategies and things for the addition and subtraction pretty well figured out. Okay. Well, good. But teach him a strategy for multiplication so he can stay with the class while he's learning them.
I just wanted to find out if you think it's a good idea to backtrack to help him out with this understanding. I don't think he ever had any of this understanding.
If you think it would be helpful, if you can try and ask him if it's ask him. Say, I learned something new and I'm going to show it to you, and then I'm going to let you try it if you want to, and see if it's something that you can use for when you get stuck. And that's what I do when I teach classes this. It is for when you get stuck. Okay? When you learn it and you know this, I've done this sheet now 4 weeks, 5 weeks, 6 weeks, wrong sheet. And I'm learning a lot of these because I've done them for my mom every day. And I'm doing them and I'm getting the same answer. That's something else that if kids are counting, 8 plus 7 can be 15 or 16 or 14, or maybe they just look at it and say 19, I don't know, something. It's not consistent because they're making mistakes or they're guessing. With this, they see the answer to the fact is the same every time they do it. It's consistent. That really helps with memorization. Okay? And then eventually they can do mentally. They look at, I know a school principal in Pittsburgh who still does this to this day. She invented this herself when she was little and says, she looks at 8 and 7 and says, okay, 3 and 2 is 5, it's 15. She uses that mental strategy. She doesn't know 8 and 7 is 15. She doesn't bother to learn that 8 and 7 is 15 because she looks at it and says 3 and 2, 5, 15. That's it. And they can do that until they get it memorized. If they never do, they have something that's workable. Obviously, the principal is doing quite fine with 3 and 2 is 5. So that one kind of took me by surprise, but I was kind of pleased. Okay. She was doing what I was doing. Yeah, she taught herself how to do that. None of this is something that I invented. It's just that I put it together in such a way that there's one decision. I think that's what I brought to the table that's really different, is that they only have to choose once. I count or I don't. That's it. Shall we move to subtraction? Okay, this one was the one that took me a year, and I tried to base it on that 5 plus 1 and the 5 plus 2s because I wanted it consistent with everything I was doing. Didn't happen. There are too many ways to go wrong in subtraction. So the decision point for subtraction, I'm going to need 2 hands again. Thank you. The decision point for subtraction is, do I have enough fingers? Okay, do you suppose your kids can manage that one? Do I have enough fingers? That's the decision point. Okay, I'll wait for you to get these slid in, and then we'll go on. Okay, now just ignore the sheet that you've got there. It's ready to go, but we're just going to ignore it for a minute. I'm so sorry. I have to have 2 hands. Okay, if I have enough hands to subtract, I'm going to use my fingers to subtract. That is the quickest and most efficient way of doing it. But I am not going to count the fingers. That's what's different about it. If I have 10 and want to take away 6, what am I going to fold down? 5 and 1, okay? You've already taught your child how to put 6 together, or take 6 apart, 5 and 1. Now you're going to say 5 and 1. Now I look at the fingers, and I've learned how to recognize 4. I know what 4 looks like. I have 4. I read the number that I'm bringing down, and I read what I've got left. I do not count anything. It's very fast, very efficient, and it certainly beats going, let's see, here's 7. And then I have to count backwards. Oh gosh, let's see. 6, 5, 4. Okay. Now, I've got 4. I said 4 and I have 4, but they don't usually come out. Or you go 7, take away 3. Okay, let's see. 3. I haven't got a group of 3. I've got 2 and 1 though, right? I can take 3. So you say 3 is 2 and 1. They should be able to compose and decompose their numbers by now. And what have I got left? 4. Okay? So if they have enough fingers, they need to fold the fingers down in groups. They need to look for groups. If I'm subtracting 5, that's a group that's really easy. They love subtracting 5 with this method. 7, take away 5, bam, 2, that's it. 7, take away 2, bam, 5, that's it. Those combinations, they're going to learn those very quickly because they know that 7 is 5 and 2. And then they're going to learn really quickly that if I'm taking the 5 away, the 2 is left. I'm taking the 2 away, the 5 is left. They've seen it, they've heard it, they've felt it, it comes. They learn it very quickly that way. So I go all the way up 9, I'm subtracting from 9, I'm subtracting from 10, I'm taking groups away. Sometimes, like if you have 10, take away 2, there are several ways they can fold their fingers, whatever's comfortable for them. You can take these 2 down. You can take these 2 down. You know, or your child can fold these 2 down if they like that. It's very uncomfortable for me to do that, but that might be what's suitable for them. Let them find something that works for them. Does it have to be consistent? No, as long as it's taking down 2 and they can see, oh, I'm going to take this 2 down. Some kids have fun with it and decide they're going, this time I'm going to put these two down, this time I'm going to put these two down, this time I'm going to put these two down. But they always have how much left? 8. Thank you. And they can read that that's 8 because they can see that it's 5 and 3. And they know 5 and 3 is 8. So they are not counting. And if they're used to doing this, if they're used to counting because they're in a higher grade, they've done this, they've made their own strategies, they've struggled with it, figuring out what to do, and they feel more comfortable counting back, time them counting back, and time them with taking the group away. Most of the time, and that's after you've had a chance to practice with them. Because obviously the first day it might be a little slow thinking about what to do. But most of the time, with any children that I worked with that were kind of concerned about, but I like it my way better, I said, well, do you want to do it fast or slow? Fast? Okay, let's see how fast yours is. Let's see how fast mine is. Oh, well, maybe I'll think about that again. And then they've come, thank you. And then they come around. So that's, if I have enough fingers, I subtract it from the fingers. What do I do if I don't have enough fingers? That's the strategy that's on your sheet. Okay? And guess what? Look at that 13. What does that 13 mean? 10 and 3. We're being flexible again. We've already talked to them about the teen numbers. They know about the 10 and 3. It comes in play right here. It becomes a useful thing to know because we're not going to subtract from 13. We're going to subtract from the 10. We're going to use the 10. And we have enough fingers to use the 10, right? And we already know a strategy for using our fingers from 10 because we have that. And if you want to start memorizing facts with kids, the sums that make 10 are a really good place to start. Okay? Doubles, 2 plus 2, 3 plus 3, 4 plus 4, and tens, 6 plus 4, 7 plus 3, 8 plus 2. There's only 4 they really need to work on because most of them get 5 plus 5 right away. But you can work with them and learn that 6 plus 4 and 4 plus 6 are the same thing. So that's only one fact. 7 plus 3 and 3 plus 7 are the same fact. So they only have 4 to learn. And when they do that, they won't even have to use their fingers to use this. So here we go. That requires elbow grease. Okay. So here's 13 minus 6. Now, again, you start written, or you start with base 10 blocks, or you start with a 10 frame, or you just put 10 things, and I recommend doing it this way, 5 and 5. It's easier for a child to see, and that way, if you have this many, you can see that it's 5 and 2, and you can read it as 7. Then later, you'd move on to written, and this is the written strategy. You have 10 plus 3, right? Now, I'm going to take 6, not away from 13, but away from 10. And if I know my facts of 10, then I can do that mentally. If not, I can use my fingers. But I'm going to cross off the 10, take away 6. So put 10 fingers up. Okay, now take down 6. Think about 6. What are you going to take down? 5 and 1. What have you got left? 4. And you just read it. You don't count it. So I put the 4 here. Now here's the 3 that I didn't use. I add the 4 with the 3. 3 is a counting number, so I can count up. 5, 6, 7. 13 minus 6 is 7. It's very quick. It's a whole lot quicker than trying to figure out how to get 13 fingers up there. Because that's a losing proposition. It really is. So they subtract from the 10. It's something they can use their fingers for. It's something that they can use those facts to 10 for, and the teachers will emphasize facts to 10. 10 and 6 and 4, 7 and 3. Looking to make a 10 is something that most textbooks teach. So they're going to have this reinforced it in school, and you're going to reinforce it at home, finding the sums to 10. So now I have 7. What do I do if I have, let's try 13 minus, think of one that doesn't, 4. Okay. Okay. And what are you going to write over here? 10 plus 3. Okay, and they've learned that this is okay. 10 minus 4 is, put up 10 fingers. There we go. Look for a group of 4. Do you see a group of 4? Those 4 right there. They're always there. Because if you have 5 or more, those 4 are always included. So take down 4. What do you see that's left? 6. So you cross off the 10, put a 6. Counting number, so I'm going to count up 7, 8, 9, 9. Okay. Does that make sense? I can't believe it took me a year to do that. You cannot imagine how many times I went through the entire set of 100 subtraction facts and trying out my latest version of how to use the 5 and the 1 and the 5 and the 2 and the whatever. And I would always hit a snag. And then all of a sudden it's like, oh my goodness, the answer was here all along. And it really does work. So let's move on to multiplication. Are there any questions on the subtraction, by the way? I included pictures to show you that there are different ways to do this, kind of to remind you what they can look like. Again, let your child do it the way that's comfortable, because some hands are put together differently. And little hands aren't going to get the fingers all the way down. They're going to kind of dip. Okay, good question. Thank you. Okay, the question that was asked, and I'd like to address this, and I'm glad she reminded me. What do you do if you've learned this strategy, but now you have to subtract 23 minus 6? Here we go. 23 minus 6. Can you take 6 from 3? No. What do you have to do? Go get a 10. Here's the 10. Now I have the 10. What do I subtract from? The 10. And I can do this mentally. If I've practiced, I can just say 10 minus 6 is, and I can do it on my fingers if I need to, 4. And then 5, 6, 7, and I put the 7 there, and then I bring down the 1. Again, they will learn their facts, and you can practice the facts. But meanwhile, they can do all the problems that they're supposed to do for homework, all the problems in their book, all the problems on a test, and they have everything they need, and none of it is cheating because they own all the equipment. It's theirs. They're using their brain to access it. Okay, so multiplication. Have we got the thing slid in yet? This is fun. And this is the one I started with because of desperation for our poor third graders who just were trying so hard. Oh, and that worked out. Oh, thank you. Okay. We're going back to the 5 plus 1s again. Okay, that's why I really wanted the subtraction one to work that way, because addition worked that way, multiplication worked that way. But honestly, the fingers is the best thing that I came up with in a year of trying. And I would sit, every television show I watched for that whole year, I was busy writing subtraction facts. So, and you go, and how come it took you that long? Because I wanted it to work some other way. Sometimes you have to just let go. Okay, here we go. I think 6 times 7 is the one that starts. But let me show you what you're going to do with your children, and this is important because this can be done absolutely by rote. You can just teach them to learn to do the procedure, and this is how it works. What you want for your children from this procedure, especially in multiplication, okay, good, is is an understanding of why it works. If they don't know why it works, it won't make sense. And what are we looking for? We're looking to make it make sense. If your children understand numbers and they make sense, they will do well in math. They will enjoy math. And this is a key piece that is critical to understanding algebra. It's called the distributive property. And I didn't write that down, so you can write it. And don't go all shivery on me because it's algebra. I know some people don't like algebra. It's okay. This is easy. And you're not going to tell the kids that it's the distributive property. I just want you to know that so that you know that that's what it's called if you're interested, and what it's about and how it's going to apply to algebra. So here's 6 and here's 7. So you want to draw. Now they know about multiples. So they can say, well, 6 times 7 means how many 7s? 6 of them. So I'm going to make 6 7s. Okay? 1, 2, 3, 4, 5. See? 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? Now, you ask your child, will you agree that this is 6 7s? They count and they go, okay, 1, 2, 3, 4, 5, 6. Yes, those are 6 7s. And so 6 times 7 would be what I get when I count all of these, right? And they'll go, uh-huh. And then you go, I don't want to count all of those. That's too many to count. Would you agree with me that it's too many to count? Your child will say, uh-huh, it's too many to count. They will definitely. Well, I said, I'm looking at this and I'm thinking, I know how to count by 5s pretty fast. You know how to count by 5s? What if I put all the 5s together and I counted them, just the 5s? Would that be easy? Okay, let's do that. 5, 10, 15, 20, 25, 30. So I have 30 here, right? Okay, they agree with you that yes, that makes 30. And look at this. I know how to count by 2s. I'll bet we could count all of those too. And you circle it. You see why I put them in the way I did now? Very deliberate. I hope you're writing this down. This is important. 2, 4, 6, 8, 10, 12. This group has 12. You want to show them physically that 7s are groups of 5 and 2, and you can use the 5s and you can use the 2s. Okay? This is important. Now, how many 5s did I have here? 1, 2, 3, 4, 5, 6. So could you say that 6 times 5 was 30? Is that part of what we did? Is that a good way to write it? Yeah. How many 5s were there? 6 of them. 6 times 5 is 30. If you're more comfortable putting the 5 up here and multiplying by 6, that's okay. It says the same thing. And how many 2s did we have down here? We had 6 of them. So I had 6 2s here, and that was 12. Now, if I added 30 and 12, will it make 6 times 7? Well, I had 30 here and I had 12 here, and that made 6 times 7. So it would be the same here, right? Okay. You get them to agree that. You make sure that they're convinced that that works. If they believe it now, they'll believe it later. If they don't understand it when you're going in, it will be nothing but rote memorization, and there are always places where you forget what you memorized and you do it wrong, and you have nothing to rely on to reconstruct it. Okay, so now, pretend that's still there, because you're going to have more room than I do on this board. What if I wrote the 5 here, the 7 here, and I wrote 5 plus 2? Is that okay? We've learned that that's 7, yes. Well, now remember when we had, and you point back to the 6 times 5 and the 6 times 2, don't I have the same thing here? Could I go 6 times 5 is 30? And I'm going to write it down here because I don't have room, but you would write it under the problem. Can I say 6 times? I'm sorry, was there a question or? Okay. 6 times 2 is 12. We put that down there. Now we can add that, and what is it? 42. What is 6 times 7? 42. But we used what we already knew. Now maybe they don't have their 5s memorized, but they can count by 5s. They might not have their 2s memorized, but they can count by 2s. When they're learning multiplication, most of them have learned how to count by 2s and 5s at that point. I have special ed teachers who are using this, and it's working because they can count. Okay, so that's the method that you're using. And I call it splitting. You can call it anything you can want. You can call it decomposing, which is what it really is mathematically, and tell the kids that's what mathematicians call it, and then you can give it some other name. Okay, what's the next one on the sheet? I forget. 7 times 8. Okay. Usually I say that you can split either number that you want. Kids get a preference for using the 6, because 5 times 1, it has a 1 in it, and they like multiplying by 1, or the 7. This is not a choice on this one, and I'll tell you why not. What are the things that kids know for sure when they start multiplying? They can multiply by 0. That's not a fact to learn, that's a pattern. They can multiply by 1, a pattern, not a fact to memorize. They can count by 2s. They can count by 5s. And there's a trick for 9s that they totally, absolutely love that's on your page, and we'll get to that in a little bit. What's left? Well, what's left is what's on this sheet. May I? And this sheet has every single multiplication fact on it that does not have a 0, 1, 2, 5, or 9 in it. That's all that's left. That's all they ever have to use this strategy for. And they'll memorize the 3s pretty quickly, and the 4s, and they'll be stuck with the 6, 7s, and 8s. And these go very quickly. This is a good backup for the hard ones. Okay? So, what number? I can split the 7 with 5 and 2. I can split 6 with 5 and 1. I can split 4 with 2 and 2. I can split 3 as 2 and 1. But 7 times 8 has a number in it. Show me 8 on your fingers. 5 and 3. Is 3 up here on the easy ones? No. I can't guarantee that when I work with a group of children that everybody's going to know their 3s. Now, you'll know your student, okay? But I wouldn't start out splitting the 8 because it has that 3 in it, and 3s are harder, okay? 3 you have to have memorized, okay? If you don't have it memorized, then you have to do the strategy with the 3 before you can do the strategy with the 8, and that's a pain. So what are you going to split there? The 7. Just teach them. We don't split 8s. Now you see the box around 8 times 8 down in the near the corner? And it says just learn it. I don't recommend using this strategy to get 8 times 8 because you'll have to know your 3s first. Now I have had students who have practiced this, and then when they learn their 3s, they start splitting the 8s. If your student does that, yes, that's great because it's making sense to them. You didn't teach them to use 5 plus 3, but they're going to go ahead and use it anyway when they feel that they have the need because they already know the 3 and that makes it easier. Great. If they haven't, now most of the time I make them put that 64 in the box before we even start the sheet. So it's like, what is 8 times 8? 64. Okay, and it's memorized in a couple of days. But your student might be different and just want to confirm it, and that's okay, but not at first. I wouldn't teach them to do it that way. If they're comfortable with that, they can do anything they want at this point because that's what you're teaching them, to be flexible, use their brains. So where are we? 4 times 8. What would you split? The 4. And how do you split it? 2 plus 2. I'd like to hear a little bit more. Okay, so they do 2 times 8 is 16. 2 times 8 is 16. A lot of the kids love that one, love their 4s, because they only have to figure out 2 times 8 one time, and then they just put it down again. So that's a good one. I like that one, Mrs. Foster. Okay, good. Anything that they like about math is great with me because I love it. All right, next one is 7 times 7. So does it matter if you split the one on the top or the one on the bottom? Not a bit. Okay, so you can write it this way. And you can cross off this 7. And it's 5 7s is 35, and 2 7s is 14. And by the way, if they haven't memorized their 5s, they're going to practice them every day doing this strategy. And they're only going to have to count it about 20 times before they get tired of counting it and decide they know 5 times 7 is 35. And the same thing with 2s. They're going to start remembering the 2s because they're going to do this every day with you. And that's what I recommend that you do with these sheets, is if you're working on this strategy, do it every day. But don't do the whole sheet if it takes longer than about 5 minutes. You just want a few minutes of practice. What if they don't get to the bottom of the sheet for a long time? That's okay. Because we're not practicing things that are specific to those facts. We're practicing a strategy that works for all of them. So if they learn to split a number on 6 times 7 and then they get 4 times 4, they will have the strategy and know I'm going to split one of those and use 2 plus 2. Does that make sense? So 5 minutes, and then see if they can get another problem done. Set goals for them. You've been getting 4 of them done in 5 minutes. How about today we try for getting 5 done in those 5 minutes? Okay? See if you can get 6 done in 5 minutes. Let me time you and see how long it takes you to get 6. Kids love playing beat the clock. So if you want to play beat the clock with the kids, make sure that you set a time that they can beat. Okay, watch them. See how long it takes them to do, say, 3 problems. And then set a time that's a little bit longer than that. Let's see if you can do it in 3 minutes. And you've seen them do it in 2. So you know that they can do it. Set it for 3 and say, okay, let's see if you can beat the clock, and they'll beat the clock. And they get excited. I don't know what there is about beating the clock, but they love it. And so then you play it again with maybe more. Let's see if you can do 4 of them in 3 minutes. But you've watched them do it, so you know that they will. Okay, and so you keep doing that for a while. And then after they're really into it, then you can start moving that clock time down so it's really pushing them. But not at first. At first you want them to beat the clock every time so they get that feeling of success. And that sustains them through the couple of times that they don't beat the clock, but they know they can do it the next time. Okay? Okay. Do I have any questions on multiplication? Okay, good. Uh-huh. If they need the strategy, write it off to the side. And they will learn it. That's something else they can practice while they're doing this. There's a lot of practice in addition and multiplying some of the smaller things that's built into this, but they don't notice they're practicing it because they think they're practicing multiplication. So they don't want to do addition anymore, maybe in 3rd, 4th, and 5th grade, but they don't mind practicing multiplication, and now they're practicing their addition too. So yeah, if you have a child that's struggling with 6 plus 6, and they keep hitting that, then just have them do the strategy off to the side. And because if you haven't taught it already, because a lot of you are going to start with multiplication, I'm sure. If your child is in 3rd, 4th, and 5th grade, that's the key facts that they need. That's the one they're going to struggle with the most. And then if they have issues with addition or subtraction, go back and pick that up after they're comfortable with what they're doing in multiplication. Don't try and teach it all at once. Not a good idea. But you need them to get comfortable with one and then move to the other. And again, it's a backup strategy. Okay, this works for all of your kids, whether they're struggling or not, because it gives them that flexibility with number that they're going to need. Now let me show you how this works for algebra. If you write it that way, 7 times 5 plus 2, they've been doing that. 7 times 5 is 35. 7 times 2 is 14. Oh, I've been doing that. I know how that works. And if they're getting into something where they're going to need to use that in algebra, take them back to what you did here and say, but you've already done that. You can learn, save this up in your brain for 7th or 8th or 9th grade and use it when it comes in. This is distributive property. I multiply this times this one, and then I multiply it again times this one. That's the simplest form. Then what does it look like in algebra? Oh gosh, I've got a y on the outside, and then I've got a plus x inside. Oh, that's what you've been doing since 3rd grade. Remember when I taught you how to do this and this? Same thing. Here's the y, and here's the something or other in the parentheses, and now we're going to split it. A plus x, a times y is ay, plus x times y is xy, and that's what you're going to get. Oh, I've done that before. No problem. You've taken all the worry out of it. There's the y times the a, there's the y times the x. They write it down. And it says, oh, just like I've been doing. That's the distributive property. And kids that can't do this, don't understand what to do, they try and multiply this and then add this on or whatever. That's one of the major stumbling blocks for kids learning algebra, is not understanding distributive property, how you can split something, how you can have 2 pieces multiplied times 1 piece. Okay, and that's the property that connects addition and multiplication. There are a lot of properties of addition. There are a lot of properties of multiplication that you learn in elementary school that apply to algebra. It's the same things. Algebra is basically arithmetic with letters. And this is the big property that ties them both together. And if they don't get that, then they just really struggle. And you're going to teach it to them way down in 3rd grade without telling them. But just keep it up in your brain and hold on to it till they get to algebra, and they're going to love you for it. Because I know their teacher isn't going to explain it that way. Their teacher doesn't know that you can split the 7 and multiply 5 times 6 and then 2 times 6. But you do, and they will. Okay, any other questions? Yes, thank you. Mm-hmm. Okay. Okay, now I'll show you 2 ways of this. Okay, sometimes people will split this number, and you will have the 40 plus 7, and then you multiply the 7 times the 40 and the 7 times the 7, so you have a 0 here. This is 280, and then you do the 7 times 7 is 49. My mouth knew what it was, my fingers did not. 49, and then you add those 2 together. Okay, you're asking about doing it the other way. Okay, so let's see if I can figure this out. 47, and I make this 5 plus 2. So I'm going to make 2 different problems. I'm going to multiply by the 5, and then I'm going to rewrite the 47 and multiply by the 2 to start with. Now, if your child can be mentally flexible enough to go 5 times 7 is 35, 5 times 4 is 20, plus 3 is 230. Okay, now I'm going to use the 2. 2 times 7, pardon? Oh, okay. Yeah, there you go. And then, by that time, you multiply the 2. But make sure, this is the only tricky part, and you have to make it very clear, is when you're multiplying by this 2, it is not like you are multiplying by 52. This is not a 10, and this is not the 1s. So there is no 0, okay? So I don't recommend doing it that way simply because it's a very confusing thing to do. I would split it and write it out in 2 parts if they were really stuck. Or I would do the, if it's just the 7 times 7 they're stuck on, then I do it over here. Okay, again, my fingers don't always pay attention. Is that too small for you to see? Sorry. So you start here, and I just check what the 7 times 7 is, which is 35, 14, 49, and then I take that information back over here. I just do it on this side, or even on a piece of scratch paper where my teacher is never going to see what I'm doing because, you know, they get a little embarrassed if the teacher doesn't know what it looks like. And they don't want to have to deal with telling the teacher, what are you doing? Oh, no. I don't want to tell you that my mother taught me that. It's embarrassing. But it works for me, so I keep using it. So I take the 49, I put the 9 back here, and I regroup the 4. And then I do 7 times 4. If I haven't memorized that one, I go over on my little scrap of paper that nobody's going to see but me, and I put the 7 times 4, and maybe I'm going to split the 4 this time, and I get the fact, and then I take it back over here. Hopefully, they will be memorizing a lot of these before they get too far. But if your child is in 4th or 5th grade and has struggled with this and hasn't memorized the facts yet, or hasn't memorized all of them, you know, they are going to come up against this. They're going to multiply by 2 digits in 5th grade, and they're going to be checking those facts a lot. Is that okay? Yes, it is. But I would teach them to do it on a little piece of paper where the teacher isn't going to see it, and then they don't have to be worried about explaining it to anybody else. Does that answer the question? Probably more than you wanted. And somebody else over here had a question. Oh, okay, great. Yes. Talk to my mother. No, really, because I have dealt with that. And that's my first answer is put it on a piece of paper the teacher isn't going to see. If you're doing it for homework, do your work on the side and then put the answer where you need to have the answer. Is that okay? Yes, it is. Okay? And if it's a test at school, math teachers give you scratch paper. You're supposed to have scratch paper to work with, so you put it on the scratch paper. And then most teachers don't collect the scratch paper. If your teacher insists on having it on the paper, I want to see everything you do, then you put it on the paper and you explain that my mother taught me this, but I'm learning my facts. These are just a few that I haven't learned yet, and this is how I get it right. And if you want to know more, talk to my mom or grandma or whoever, right? But yeah, I do recommend that kids do it on a separate throwaway piece of paper if they have any indication that the teacher isn't going to like it. Most teachers are thrilled to death. I'll tell you what, most 3rd, 4th, and 5th grade teachers are going to be so happy that this kid has some way of finally figuring out what 6 times 7 is instead of guessing it every time. They'll love it. And does this work quickly enough that a child can keep up in class? Yes. At one of the schools I worked at, we had a time test, kind of a club, where if you passed your facts, 100% club, you had to get all 100 of the facts in a certain length of time. It changed with the grade level. You got ice cream party every quarter. You got invited to the ice cream party if you could pass your math facts. So these kids, of course, that don't have a clue how to do 6 times 7 are never going to pass that test. With this strategy and being able to figure out the few that they didn't have memorized, I've seen, and I didn't bring them tonight, I do have them, where kids are using the strategy right next to those facts in little teeny spaces. You've seen the time tests, so you know how little they make them and how close together they are. And they're still squeezing the strategy in next to the problem so they can get the answer in the right place and move on. And they're passing their time tests with it. They're not using the strategy with every fact, but they're using the strategy for, say, 5 to 8 facts, the ones that they get stuck on all the time, and they're still passing the time test. They still get 100% on their time tests. So I'd say that was fast enough. They can learn to do it if they're practicing it every day and get the idea of the strategy. And you know what? Guess which fact is the first one they learn when they practice this sheet every day? Look at the sheet. Which fact do they learn? Not 8 times 8, with the ones that they're using the strategy for. Yeah, hopefully they learn 8 times 8 first. 6 times 7, why is that? It's the first one. If they haven't done anything else, they've done that one every day. Pretty soon, they're going to want to, Mom, can I just write down 42 instead of doing all this stuff? And you go, well, I guess so. And inside you're going, yeah. But you know your child, you know which approach. But I'll tell you, I've had some stubborn little 3rd grade boys that were not going to learn their facts, absolutely not going to do it. So they had to do this every day. After 2 days of this, 2 days, they marched up to their teacher, all 5 of them, and said, we're not going to do this anymore. We're just going to learn them. And the teacher says, well, I'm sorry you feel that way, but I guess I'll just have to accept it. And inside she was doing the happy dance, but she didn't tell them because they thought they were being just so rebellious. I'm going to learn them instead of doing this strategy. Are there any other questions? We've just got a few minutes left. Okay, I want to give you my email. So write it down someplace. If you have questions later, please email me. I answer all of them. Did I write it down there? Oh, I'm so smart. Sometimes. Okay, great. Please feel free to email me if you have questions. This year, next year, in a couple of years when your child gets older, whatever. I'm glad to do that for you. You can kind of tell I like math. Okay, thank you. Sorry, one more question? No, division. Division I haven't figured out yet, but I'll tell you what to do about division, because I don't think there's going to be an easy way to do division. There's a doing 2-digit division, there's an alternative algorithm that can be done. And if you email me, I have an explanation for it, and I would be glad to send it to you, that gets them through 2-digit division in 5th grade. And the kids love it. Again, some teachers are not going to like it. Have them do it on the side and do it the right way, you know, but you can figure that out. But yeah, but for division facts, I always tell, for division facts, I always try to get kids to learn the division facts as they're learning the multiplication facts. I don't want them to learn 12 divided by 3 is 4 as much as I want them to learn 3 times what is 12. 4 times what is 12. Teach it as a missing number of the multiplication fact, and in their brain, they connect it to the multiplication facts. So when they learn the multiplication, they also learn the division. There are many children, and they've done brain research. They can watch the activity in your brain, where when a child is doing multiplication, one area of his brain lights up, and when a child is doing division, another area of the brain lights. They are not connecting those facts. They are learning them as 100 completely separate facts. That's not a good use of your brain power. If you can make that connection for your child, thank you so much for bringing that up. If you can make that connection by asking your child, okay, so 3 times 4 is 12. So 3 times what is 12? 3 times 4 is 12. Oh, so 4 times what is 12? Oh, 4 times 3 is 12. And just get them to say them. Don't tell them it's division yet. Just get them to start thinking of it that way. When they get to division, say, well, 12 divided by 3 means something times 3 equals 12. Something times 3, oh yeah, it's 4 times 3. Make that connection back to multiplication. And if you've asked it with missing numbers, they will immediately understand what it is you're asking for, and they can make that connection very quickly. Thank you so much for asking. Anybody else? Okay, thank you so much.